Okay, in this video, I'm going to walk you through this question here about a student riding a rotor at an amusement park, and we have to prove that this relationship down here is valid. So I have my rotor here, and I'm going to put my little person on the rotor. So my person right there, and then I turned him or her into a dot right there. All right, because they're riding the rotor, I'm going to write down the centripetal force equation, Fc equals mv squared over r. And I'm going to replace Fc with the force that's going towards the center when you ride the rotor, and that is the normal force. So Fn equals mv squared over r. And I'll go off to the side and say that friction equals mu times Fn, which means Fn is going to be Ff over mu equals mv squared over r. And when I ride the rotor, we have the weight vector pointing down. We'll call that mg. And we have to have a vector pointing up that's the same length to keep my person in the same plane when the floor drops. And that would be friction, because he wants to slide down in terms of the direction of Fw, and friction would be acting opposite him. So I'll say friction. So friction actually equals Fw in the situation of a rotor. So I'm going to replace the F with mg. So now I have mg equals mu equals mv squared over r. So I'm going to cancel those m's, and I am going to solve this for v squared just because I think it's going to turn out to be a little bit easier for us. So that will be, I'm cross multiplying, so gr over mu. All right, so the next thing that's going through my mind is when I saw in this relationship that they have a t and they have the 4 the pi squared, I know where that comes from. That comes from taking velocity and breaking it down to distance over time. So when you go around the circle, the distance around the circle is going to be circumference, so it's going to be 2 pi r, but I got to square it because it's distance squared over the time it takes to go around the circle. It's going to be period squared. So this relationship is distance over time squared equals gr over mu. And so I'm going to try to do two things at one time. I'm going to solve for t squared. And so I'm going to cross multiply. So I'm going to get mu and then 4 pi squared r squared over gr. I can cancel this squared with this here. And you can see that if I take the square root of that mess, I will end up with exactly what they have down here. Okay, hopefully that helps you on that particular question.